Let's start with our interactive first exercise. We're going to talk about what learning is and what we can do to make it more effective. And so the first thing I want to ask you is to help me define what the word learning means. Anyone got some ideas? We'll put them up here. Anything.
Acquisition of new knowledge.
Whoa, 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 whoa.
Acquisition of new knowledge.
Acquisition of new knowledge. I heard another one over there.
Permanent change in behavior or knowledge.
Exchange of ideas.
Exchange of ideas.
Making new pathways in the brain to store knowledge.
I like that one.
Changing your mind's view.
Changing your,
Mind's view.
oh, changing your mind's view. One more?
Critical consciousness.
Critical.
Consciousness.
Okay, so there's some themes there. One of them is change. One of them is that it has something to do with what's going on in the brain, in our consciousness. And it's something about new knowledge. So I'm going to try and combine those into what I'm going to give you in the next slide. But before that, I just want to outline where we're going. I've got 4 books that I'm going to review, about 5 minutes each, that have something to do with pedagogy for today's professor. So here's a definition of learning that I think, well, I'm biased, of course, but I think it encompasses a lot of the things that you have here. It's the process of constructing new personal meaning in your brain, in your mind, on a foundation of prior knowledge and experience. And what we're going to see is every learner has different prior knowledge and therefore constructs different new meaning that's personal to them. And we have to keep in mind that learning is an individual process. And then there's a book I'm not going to review, but I just got last week, How Learning Works, 7 Research-Based Principles for Smart Teaching. And it defines it in a way that's consistent with what I've just put at the top of the slide. It's a process, it involves change, and it's something that learners do. It's not done to them. So it's their responsibility to do it. So the first book I'm going to look at is a book that came out in 2000. Well, first it came out in 1999, and then it was updated in 2003. It's almost 400 pages. It's put up by the National Academy Press, and it's a report of some National Research Council committees that looked at what learning is all about and what we have learned through neuroscience, behavioral science, cognitive science over the last 20 to 30 years. And I'm just going to pick some of the themes. This is a book with a lot of good stuff in it. The first one is the role of prior knowledge, as I pointed out in that definition. Every learner has prior knowledge. It varies widely between different learners. And the prior knowledge may be naive. In other words, they don't really have the right idea, but it works for them so far. And so what learning involves in that case is they have to come to terms with the fact that maybe their model for the world or for that topic needs some rethinking. And rethinking requires effort. And the role of the instructor is to encourage them to question their prior knowledge and not necessarily discard it, but build some new personal meaning on it. The second theme is that learning is an active process. And learning is done, as I pointed out earlier, by learners, not by instructors. And therefore, they have to take responsibility and therefore take control. And as we're going to see in a few minutes, the degree of learner engagement, getting involved in their own learning, is very highly correlated with successful learning achievements. And active learning does not exist in the instructor giving a lecture. That's not active learning. There's all kinds of other things that are active learning. And there's been some research that has shown that as far as content mastery is concerned, active learning is just as good as lectures, but it's way better for thinking and communication skills. The third theme is that it's not just enough to learn some facts. You have to somehow be able to put it in context so that you can apply it, so you can understand it, so you can adapt it. And one of the definitions I came across is usable knowledge, which means that you've got to be able to organize the facts that you may be dealing with in some kind of framework, in some kind of concepts. And I'm introducing the word here, metacognition, for the first time, and that is understanding what it is that you're learning and where you are in the learning process for a particular discipline. I attended a lecture given by a guy called Danny Edelson, teaches at Northwestern University, and he points out that in his view, learning has 3 stages. First, you've got to motivate the learners. Second, you've got to construct the new meaning. And then third, you've got to organize it for use, just as we pointed out. But you notice that in the bottom of each box is the word reflect. And reflecting on what you've learned or what you've just done, to me, is synonymous with metacognition. You understand what it is you're doing. And then the next theme is adaptive expertise. And this is talking about what is a novice learner and what is an expert learner. And some learners become skilled, and a skilled learner will approach their assignments with enthusiasm, with flexibility. In other words, they're willing to go in new directions. They have curiosity. They look at the learning as an opportunity to explore and expand what they know. And it used to be that we thought of experts as someone who knew all the answers. That's not the conventional wisdom now. It's people who are highly metacognitive, who use what they've learned and are continually questioning what their current expertise is, looking to move beyond that. And they turn out to be lifelong learners, which is a good thing. The next text that I'm looking at is a Taxonomy for Learning, Teaching, and Assessing, which is a revision that came out in 2001 of an original version of this, which was authored by a guy called Benjamin Bloom and a committee that he chaired in 1956. So it's been around for 60 years. And what they're doing is looking at a framework. So there are 6 levels in Bloom's taxonomy. The lowest level is remember. In other words, you can recall some facts. But as we've just seen, that doesn't organize them for any reason. So the next one is understand. So you can actually put them into some kind of context. But that doesn't mean you can do anything useful with them. So the third level is apply. Or you can actually apply it to understand something. And the fourth one is analyze, where you can tear something apart, look at the constituent parts, relate those to some overall structure. The fifth one is being able to make judgments based on given criteria and standards. And the sixth one, the highest level of learning, is create, where you're assembling the elements into some kind of new pattern or functional whole. And these are usually identified by having active verbs in synthetic assessment questions. In other words, if there's a question that starts with the word recognize, then we know that's in the first level. If there's one that starts with the word design, then we know that's in the top level. So, exercise number 2. Think of one learning outcome for a course that you've already taught or you intend to teach, and pick an active verb, and I'll write down the first 5 that are yelled out. Active verbs. Diagram. So where would you put that? I'll go back one here. In these 6 categories.
Analyze.
Sorry? Analyze? Yeah, that's sounds right. Another one?
Compare and contrast.
Yep, let's just use one of those, compare. And I would say that's in the same, well, no, I'd say that's evaluate. No? Next one?
List.
List. Ah, so there we are. So list, to me, is down at remember. Another one? Identify. Where would you put that?
Maybe understand.
Yeah. Now, when we talk about learning objectives, the first 2 categories, remember and understand, are often referred to as surface learning, where it's not organized for use, it's not usable knowledge. And the remaining 4 are often referred to as deep learning. Now, it's not feasible to try and achieve deep learning in every single topic that you might cover in a course. But the ones that are most closely associated with the core learning objectives of the course, you want to get as close to the bottom of the list as you can. Now, there's another dimension that was not in the original Bloom's taxonomy, but is in this new version from 2001, where they talk about knowledge dimension categories, where they divide it into factual, conceptual, procedural, and metacognitive. We've talked about 3 of these already. The difference between having some facts and being able to organize them in some conceptual framework is the difference between factual and conceptual knowledge dimensions. And I've mentioned metacognition as something that is at the bottom of this list. And so this is the table that they've created in this book, where you've got the one dimension of the knowledge dimension, and the other one is the categories of learning. And this is the example they actually used. I copied it all shamelessly from their book, where the learning objective was use Ohm's law to solve problems. So where do we put that? Well, it's use it, so it's procedural, and it's applying, so it's C3. So we've got O1 for objective in there. And then the learning activities that they suggest in the book, I'm not sure if this is what I would expect from my class, but are listed here as A1 to A7, and they fall into boxes all over the place. And then there will be a rubric in your assessment. In other words, you get 1 point if you do this, you get 1 point if you do that. And so the rubrics that were suggested, you would be able to classify a problem, a stated problem, select which law you're going to apply, select the procedure for applying it, and then obtain the correct solution. And so those are scattered all over. You see where the R1, R2, R3, and R4 are. Now, the point they're making, and they actually conclude this is not a well-designed module because you want to have alignment. In other words, if there's an objective that's in a certain box, then you want to have activities that are associated with that objective and rubrics that are associated with that objective. And we've achieved that in box C3 because it's got an activity and a rubric. But we've got A4, 5, 6, and 7 that aren't associated with either a rubric or the objective. And we've got rubric R3, which is not associated with any activity or learning objective. And so from their point of view, this needs some work. We'll come back to this. So the next book is one that's near and dear to my heart. I've used it to teach some courses to faculty, and it's called Scientific Teaching. So it's a guide for faculty in applying the emerging results from cognitive science that How People Learn book also elucidates. In fact, they refer to it and say this is the foundation for what we're trying to do here. So it's an application of the learning that is in How People Learn. It's written by some biologists with science, technology, engineering, mathematics teaching in mind, but in my view, the principles in this book can be applied to teaching in any discipline. So they have chapters on scientific teaching, active learning, assessment, diversity, constructing a teachable unit, and institutional transformation. And I think this may be more than I need to do. Okay, we've talked about scientific teaching pretty well. It's, yeah. Active learning is getting the learners engaged in more than taking notes and following directions, taking responsibility for their own learning. And group learning, problem solving, inquiry-based learning is examples of active learning. Continuous assessment. I haven't said enough about this yet, and there's a good chapter on that. And they make the point that assessment is more than grades. It both monitors and promotes learning, and if it's done right. And done right means continuous. In other words, you don't wait till a final exam to find out how badly the students have not learned the material that you thought they had learned. You have something that goes on informally, but continuously, maybe every lecture, maybe every week. There's just some kind of little feedback thing where they fill in something or have a quiz or whatever. And that gives feedback both for the students and helps their metacognition, and for the instructors so they know where there may need to be some more attention paid. And the book makes the point that assessment is the thing that drives the learning, because there's the process of reflection and analysis that's required when you have an assessment activity. And remember, that's what Danny Edelson says, you've got to have reflection at every step. And it can shape the class standards and increase the learning gains. And evidence shows that it has more impact than any other educational intervention, particularly for low achievers. In other words, they get more out of this. It helps them more than it helps the rest of the class, but it helps everybody. And they conclude that this is the heart of effective teaching. So assessment is a big deal. It takes some effort to do it right, but there are great rewards for both the students and the instructors. And then diversity. Diversity in human experience, ability, characteristics, education, cognitive styles, personalities, abilities, cultural backgrounds, and innate characteristics. And that's a resource, not a challenge. It is something that can be used. And we heard something about that in the 1 minute. Going abroad for a semester is a wonderful exercise in diversity. And so there's a lot more to be said about diversity. And this is just an example of different learning styles and how different people prefer different ways of understanding and constructing personal meaning. And then they have what is essentially a term paper for the faculty members going through this book, constructing a teachable unit. And they use backward design, where you start off defining the intended outcomes or the learning goals, then look at what kind of evidence is going to be needed to assure you that the learners have achieved those learning outcomes. So that's assessment. And then what kind of activities will engage the learners to help them get to that point of learning. And then how closely aligned are these goals, activities, and assessment. You see, there's a lot of similarity between these books in the goals that they talk about. How many of you know what the National Survey of Student Engagement is? Show of hands. 1, 2, 3. Whoa. Okay. It was discovered in the late 1990s that the best predictor of career success was how engaged the student was during their college career, not whether they came from a high-profile university or they had the highest marks in the class. It was how much effort did they put into their learning. And industry said, you guys have got to tell us this stuff. And so they fostered the development of a set of questionnaires, or, well, there's one questionnaire for NSSE, and then there's some other ones for community colleges and so on. But the idea is to, it's a self-evaluated questionnaire for students. So they answer 42 questions. We'll have a quick look at what some of those questions are. And then these are being very scientifically constructed, so they test for certain kinds of engagement, and then some kind of engagement score for that student and for all the students at a certain campus is provided back to the campus. So they have the 42 questions broken into academic challenge, collaborative learning, active and collaborative learning, student-faculty interaction, a supportive environment, and enriching educational experience. And there's a 2-page brochure that you can download from their website. And I pasted the whole thing in here. I'm just going to pick one out of each. So that a level of academic challenge would be a question, how many papers or reports have you written that were 20 pages long or more? So, engagement. Exercise number 3. For each hour in class, how many hours of outside class time should a student be expected to work, a fully engaged student? And that includes study time, reading, writing, doing assignments, doing labs, analyzing data, preparing for class, preparing for exams. All of that averaged over a semester and divided by the number of class hours. I've got numbers from 1 to 7 there. Let's get shows of hands here. Okay, how many of you think 1 hour is enough? 0. How many of you think 2 hours is enough? 1, 2, 3, 4, 5. How many of you think 3 hours is enough? Whoa, that's many. How many of you think 4 hours is needed? 1, 2, 3, 4. How about 5? 1. Okay. 6? 7? Okay. Now let's do some back of the envelope calculations here. Let's assume a student is taking 5 courses. That's a heavy load. And that each has 3 contact hours a week. And how many total hours is it reasonable to expect a fully engaged student to spend, not counting sleep and being in class and so on? I've had long discussions with many classes, and they have told me 60. In other words, if they spend more than 60 hours a week, week after week, they get burned out. Even if they're fully engaged and full of curiosity and all that stuff. That's 10 hours a day, 6 days a week. Now, you take 15 hours of class time, 3 hours times 5 courses, and you got 60 hours total, and so you've got 45 hours left over, and you guys were all right. The many vote is the right one in terms of what it is reasonable to expect. Now, what often happens is that faculty members, or at least the students think, that the faculty members think that they're only taking their one course from that one person, and that they're expected to work that 60 hours on that one course. So there is an issue here of having, and what I found really helps is I do exactly this kind of thing with each incoming class. And we have a discussion about what our expectations are and what their expectations are, and I tell them, if you're getting burned out because you're going way over that 60 hours and you can't keep up, come and talk to us. It's time to recalibrate. Okay, and so there's, I'm going to skip over these. These are more questions that are like that. And then this enriching educational experiences is, international stuff and so on. So this is a plot that I made last night of the number of universities that have used the NSSE starting from its first year in 2000 until its current year. It's gone from 276 people the first year to 1,527 people, 276 institutions to 1,527 institutions. However, in each year there aren't 1,500. There's about 60% of the subscribers that use it each year. And USM started using it in 2005 and stopped in 2010. So that was a question I had. Did something go wrong? Okay. I guess so. So the summary is, what lessons have we learned here? The learning process is becoming better understood. And that How People Learn book is a pretty good compendium of what has been learned. Learning is enhanced by encouraging active learning and learner engagement, which are, I think, the same thing. Collaborative learning, which I didn't talk a whole lot about, but the students can learn as much from each other in teams as they can from an instructor. Cognitive awareness, which is metacognition. Using assessment, I should have put the word continuous assessment activities to enhance the learning. And using the diversity of the learners' prior knowledge, cognitive style, culture, and personality to enhance the learning environment. And the third point is, well, I'm just repeating it, that the learning is accomplished by learners, not instructors, and so we have to encourage them to take responsibility. And I hesitate to say this, but this impressed me when I first heard it 20 years ago, is that the paradigm shift for instructors is to move from being the sage on the stage to the guide on the side. That's it.